Good morning to all. This is Dr. Satish, working as Associate Professor in Adama Science and Technology University. So today we are going to discuss about visible light communication. What is a visible light communication? That is, whatever the light we are using to see or to at home, these lights are going to be transfer the data from one device to another device. That means these visible lights are going to be replaced with the existing Wi-Fi devices. What the major differences between the current Wi-Fi technology and the visible light communication? So in this class we are going to discuss about the following content: background and introduction, working technology, how they are used in real time, and some comparisons, and how it is different from the existing technology, applications, advantages and disadvantages. These topics we are going to discuss about in this class. So as according to the survey, around 7.3 billion users are connected to Wi-Fi device. That is, as we know, nowadays everybody is using smartphones, and at least one smartphone is used by most of the people, and these smartphones are always connected to the internet in various forms. Either that may be a Wi-Fi device, that may be mobile data, like that. So if this number may be increased in future year by 2020, so we need to have some alternative to transmit the data. So as we see, this number of bytes per month by 2018 with the help of mobiles, 1000 wireless devices per person by 2020, that may be a mobile, laptop or tab or PDAs, whatever the device it is. And nowadays in most of the smart homes are connecting to multiple devices are connected to each other in the smart home. And if you use like this, the consumption may be equivalent to global air traffic. So according to the YouTube survey, in 2011, 140 views per person on Earth, that is around over 1 trillion views. So more video is uploaded into YouTube in 1 month more than the 3 major US networks created in 60 years. By this strategy we can understand how the data is exponentially growing with the help of multiple devices. So if we consider YouTube, within a single minute 72 hours of video is uploaded throughout the globe, and 1.8 billion HD videos every month. 25% of global YouTube views come from mobile devices. So every we can check the mail, like that every operation can be done with the help of mobile. So these mobile devices are going to be occupy more usage data than the other devices. So as per the Cisco Visual Networking Index, which was really studied in between 2010 and 2015, 48% of growth rate is. So we need to think about the spectrum we are going to use. If the data is growing exponentially like this, there we must face the shortage of spectrum. This graph is showing some comparisons how the spectrum is going to be shortaged in future for future generations. So if you consider this one, in 2011 0.6 exabytes per month, 2012 1.3 exabytes per month, 2013 like that, up to 2016 10.8 exabytes per month. So if we the growth rate is maybe increased in for future years. So in the same way, this is the spectral efficiency gains are slowing. So this is a radio spectrum shortage. we have a less spectrum to use for future generations. Whatever the spectrum we have now, that spectrum is going to be finished if the number of devices are growing like this. In this case, almost some countries are banned the sites which uses more bandwidth, like Facebook and like that. So how to fix the problem? Here we have two possibilities are there. One is either identify new spectrum or enhance the spectrum to use. Electromagnetic spectrum. This is a spectrum we have. So in this, high frequencies, ultra high frequencies, very high frequencies, super high frequencies, extreme high frequencies, terahertz, infrared, visible, ultraviolet, X-rays and gamma rays. So these are the different divisions we have in electromagnetic spectrum. Till now, the radio frequencies are transmitted with the help of first part, that is high frequency, very high frequency, ultra high frequency and super high frequency and extreme high frequency. So if you consider the space available between the radio frequency and the visible light frequency is more than 10,000 times the space is available in visible light spectrum. And also this visible light spectrum is license free. There is no need of any license to use this particular space, but whereas in this case we need to take the license. So these entire 300 gigahertz of radio and microwave spectrum. So these inventions were initiated from 1880 with the photophone invented by Graham Bell, which is the first implementation of free space optic. The technology could be integrated with existing Wi-Fi systems to reduce bandwidth problems in crowded locations where if you consider the airport terminals or coffee shops, homes where several people have multiple Wi-Fi devices. So the first prototype called Wi-Fi, which is used LEDs that are beyond the visual spectrum for humans, for create invisible cone of light about 1 meter square in which data can be received. So later on, the system up to 100 megabytes per second. So if we have a similar bandwidth, that has to be divided into number of devices, so that might be receiving just 5 to 10 megabytes per second, whereas the hybrid system could reach up to 50 to 100 megabytes to each user. So if you want to increase any bandwidth with the help of existing infrastructure, it is not possible. So that's why we need to enhance the technology. So a new technology called Wi-Fi 4 that can increase the bandwidth of Wi-Fi systems by 10 times using optical transmission via LED lights. And another technology called designed for indoor applications such as illuminating a room and transmitting data among laptop, printers, PDAs, thermostats, devices. LED based smart lighting could deliver enhanced electronic communication capabilities at reduced economic and environmental cost. Another technology called a smart light technology, which is having a 3x6 box. So in this 9 LED lights are placed and 3 photodiodes to receive the data. LED lights will transmit the data and photodiodes will receive the data. In 2012, University of California created one LED network, but that can be used to control the traffic and advertising some other purposes. The US company called LVX is developing a system for internet communications, but while already that technology was implemented in Japan. Infrared wireless is invisible to the eye and is already widely used for high-speed data transfer for point-to-point communication, where fiber optics is not available. Free Space Optic is a Canadian technology that enables optical transmission of data, voice and video FS through the air. In 2013, Russian company Stinscommon announced the development of light fidelity wireless local network called Beamcaster. Their current module transfers 1.25 GHz per second. In 2014, Csoft, a Mexican company which is able to transfer the data 10 Gbps across the spectrum emitted by LED lights. And this is some introduction part. So we'll